So how do enzymes speed up reactions? So enzymes, just like your catalysts, they speed up reactions by lowering the activation energy for that reaction. So for example, we have a reaction of A and B forming product P. If we're going to look at the energy diagram for this reaction, so let me draw a coordinate here, and mayroon tayong free energy sa y-axis, tsaka time or reaction progress sa x-axis. Okay? And what will happen is that this energy diagram will look something like this. Okay. So bakit ganyan? Kasi si reactant mo, A and B, they will have a higher energy level compared to your product P. And that's how reactions go on. They prefer forming product P kasi lower or less energetic yung kanyang free energy. Now, this is an example of an uncatalyzed or a hypothetical example of an uncatalyzed process or reaction. Okay? So, ginagawa ng enzyme is that it lowers this what we call activation energy. Alin sa diagram na yan yung activation energy? So, ito siya. This hill here, that magnitude or change in energy, okay, yan yung activation energy. Okay, so let's use the symbol E, act. Okay, ngayon, ang ginagawa ng enzyme is that it lowers the activation energy. So instead of that one, it will look something like this. So mas mababa yung activation energy. So this is now your activation energy if the reaction is catalyzed. Now, if you notice, yung energy difference between that of the reactants tsaka doon sa product, pares lang. In fact, if you were going to measure that change in energy, so this will be the difference between the energy level of the reactants and the product. So that is actually your free energy. Okay? So whether catalyzed or uncatalyzed yung reaction mo, it doesn't change the equilibrium. It doesn't change the free energy. It doesn't change the thermodynamics. What is changing here is the rate of the reaction because your activation energy has been lowered. Alright? Now, let me give you an actual example. So let's say we have the breakdown of hydrogen peroxide, okay, to your products water and oxygen at 20 degrees Celsius. Now, it turns out na yung activation energy for this reaction, if uncatalyzed, okay, we found the value, okay, to be equal to 18 kilocalories per mole. Alright? Now, if you are going to use a colloidal platinum as a catalyst for this reaction to occur, we also found that the activation energy for that, okay, using a platinum catalyst is equal to 13 kilocalories per mole. And if you're going to use an enzyme to catalyze the reaction instead of a metallic catalyst, and here the enzyme that we know the value for, okay, is yung catalase. So catalase is an enzyme that will catalyze the breakdown of hydrogen peroxide into water and oxygen. So alam natin yung value niya, that's equal to 7 kilocalories per mole. In other words, it looks like mas magaling magpababa ng speed ng reaction si biological catalyst, which is your enzyme, which is your catalase, kaysa sa isang metallic or inorganic catalyst. Okay? Maybe because, if you recall, enzymes are highly specific to their substrate. Alright? So, it probably nakakatulong yon kung bakit ganun na lang kababa ngayon compared to 18 kilocalories for the uncatalyzed yung kanyang activation energy. Okay? So, the speed of enzymatic reactions, or the speed of any reaction in general, okay, is governed by what we call Arrhenius law. So, si Arrhenius law, it looks something like this. So, yung relationship ni rate constant K and temperature na-establish siya ni Arrhenius. So, K is equal to A, which is a pre-exponential factor, which is related to the frequency of collisions kapag nangyayari yung reaction. And then, exponential, no? So, E raised to negative E act, or EA. So, yan yung activation energy natin divided by RT. R being the gas constant and T is temperature in absolute. Ibig sabihin, dapat naka-Kelvin. Ang sinasabi lang ng law na to is that may relationship si K, or reaction constant, kay temperature. And if we're going to check the equation, ang sinasabi dyan, habang tumataas sa temperature, basically, tumataas din yung rate constant. Alright? So, ang gagawin ko ngayon is to compare these three here. Or actually, let's just have a comparison between that of an uncatalyzed reaction for hydrogen peroxide breakdown into water and oxygen. So, compare ko yung uncatalyzed. Let's say that's reaction, or that's, let's say, 0.1, or just simply 1. Tapos, 2, compare natin siya doon sa kinatalyze ni catalase. Okay? So, let's see the difference in terms of speed. Now, we need to use a gas constant here. So, si gas constant natin, okay, there are different values depending on the units that you're going to use, but since we're using here calories, the gas constant will be equivalent to 1.987 calories per mole Kelvin. Right? So let's check reaction 1 and reaction 2. Actually, they're the same reactions, but again, reaction 1 is uncatalyzed. Reaction 2 is enzyme catalyzed. So, what we need to do is we just compare yung kanilang rate constants. So, K2 and K1. Ko-compare natin. So, sa K2, substitute lang natin. So, A, Arrhenius equation. E, raised to, or let me just use EXP. Pwede rin. Okay, some textbooks, they use this symbol. So, that means the same, no? EXP raised to, no? Negative. For reaction 2, 7,000 daw calories yung activation energy. Okay? Times, or divided by rather, R, which is 1.987, and T. And the temperature here is 20 degrees Celsius. That's also equal to 293 Kelvin. If we're going to check, magiging consistent naman tayo sa dimensions or sa units. Because 7,000 is in terms of calories and your gas constant is naka-calorie rin siya, and then your temperature is in Kelvin. So that's for K2. For K1, or the rate constant for the first reaction, which is uncatalyzed. So ganun din, A pre-exponential or exponent, no, E raised to negative 18,000 divided by 1.987 then times 293 Kelvin. So what will I do here is I will just take the ratio of K2 and K1. So divide basically. So that magkakaroon tayo ng value ng ratio ng K2 and K1. So si A or yung pre-exponential factor natin, mawawala lang yan, magka-cancel. So you just have to use your calculator and calculate itong nandito sa ating equation. So if you do your calculations, the result will be something close to 161 million. 161 million yung kanilang ratio. Or just arranging it another way mathematically, K2 is 161 million times that of K1. Okay, ano ibig sabihin yan? Ibig sabihin, yung rate nung reaction 2, okay, which is catalyzed using the enzyme catalyst, is 161 million faster than the first uncatalyzed reaction. So, a difference of what? 11 kilocalories lang, diba? That's their difference in terms of activation energy. So, 11 kilocalories difference resulted to the fact na mas mabilis ng 161 million times si catalyzed reaction kay uncatalyzed reaction. So that basically is how enzymes work. They lower the activation energy.